I've used up all the Sharpie juice. Okay, 33. F of x is equal to tangent of x all over sine of x. And we're asked to find the vertical asymptotes of the graph and to describe the behavior from left to right of the vertical asymptote. So the vertical asymptote occurs when what? Vertical asymptotes can occur when the denominator equals 0. Okay? So when does sine equal 0? Well, if we look at our unit circle, we remember that it's always going to be cosine comma sine. And so sine equals 0 at 1 comma 0 and negative 1 comma 0, which occurs at pi and 0. And then if I keep, so basically multiples of pi. But when we go, this is the challenge with 33, is that when I go to graph this, if I were to graph this and say sine of, oh wait, I said that wrong, tangent of x divided by sine of x, and I graph it, if I come in here and I say trace pi,
how do you get those like asymptotes?
I see that y doesn't equal that. So then as I come across here, well, y certainly isn't defined at pi, but that's not the vertical asymptote. What's the vertical asymptote? It's like 1/2 pi. Why is that? So it's not defined at pi. Look at this. If I plug in pi, I have no y value, right? But that's occurring right here. Isn't that weird? But that's not where the asymptote is. The asymptote is right here, which looks like it's at about pi over 2. Well, why is that? Does anybody know why? I know why. Well, because we're saying that f of x is equal to tangent of x divided by sine of x. But wait a minute. Tangent of x is sine of x over cosine of x. All of that divided by sine of x over 1, right? So if I think of this as a fraction and this as a fraction, well, whenever you divide by a fraction, don't you multiply by the reciprocal? Well, wait. 1 over sine of x, right? Is that right?
1 over cosine.
Sines of x cancel, and so this whole thing is equal to 1 over cosine of x. So my vertical asymptotes really occur when cosine of x equals 0. Oh wait, well where does that occur? Right here and here at pi over 2 and 3 pi over 2. Right? Because it would be 0 comma 1 and 0 comma negative 1. So I'm just guessing. What do I say then? Well, they occur at pi over 2, 3 pi over 2. What else? Take a guess. 5 pi over 2. Well, let's verify that. Let's see. Oh, wait a minute. We got one more problem. We still have in the original function sine of x. And when is that equal to 0? pi. So somewhere I've got to fit in pi and 0 and 2 pi. Now pi is actually what? Pi is actually 2 pi over 2. And 2 pi
4 pi
over 2 is pi, and this would be 4 pi over 2, and so on and so forth. So how would I write that? That's very confusing. I'd have 0 pi over 2, then 2 pi over 2, then 3 pi over 2, then 4 pi over 2, 5 pi over 2. So it's just an integer times pi over 2, isn't it? I think. I don't know. We got to verify all this stuff. So if I come in here and I hit the graph, here's what I'm going to do to make my life easier. I'm going to go table, and let's start at 0. And let's have our increment. It looks like we're counting by pi over 2, right?
Indeed.
So let's have our increment be pi divided by 2. And now let's look at our table of values and see what we get for y.
Error, 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 error.
Error, 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 error. This one should be error.
That's not. It's not.
And it looks like every once in a while we'll get a value. Well, that's weird.
Why is that?
Huh. What does that mean? Let's see if that happens again.
Oh my gosh, it does.
Boy, that's a really hard problem. So what is 18 with regards to pi over 2? 18.85.
6 5. I don't know.
Well, the first one occurs at, what is that? Isn't that, I would guess, isn't that 4 pi? Isn't that 4 times pi? Somebody do that on your calculator.
4 times 3.14 would be close to 1.
So 4 pi, you get a value. And then this would be,
6 times 3 is 18.
so it's 6 pi.
I was right.
Well, that's all over the place, isn't it?
Oh my gosh. It is.
So how do you define that? I know the answer.
So it's that's the
So how do I write that? So 4 pi, so if I were to define this, let's look at this. So this would be 1/2 pi. This would be 2 pi over 2. This would be 3 pi over 2, 4 pi over 2, which is the same as 2 pi, right? 5 pi over 2, 6 pi over 2, 7 pi over 2, looks like we get a value of 0. 7 pi of 2, 8 pi of 2, we get a value of 1. So if I look at that on my paper, and I'm running out of room, it looks like I have a vertical asymptote. Let's write this down. Let's go back. Pi over 2, right? And then 2 pi over 2, I have a value. And then 3 pi over 2, I have a value. 4 pi over 2, I have a value. Let's keep counting down. 5 pi over 2, I have a value. Right? So we've got 1, 2, 3, 4, 5, 6 pi over 2, I have a value. Which is the same as 3 pi. Uh-oh. That one looks like it's 0. So 7 pi over 2. I don't know, we got to think about that. But at 8 pi over 2, 2 pi, or 4 pi, definitely we have a value. So how would I write that down? How would you write that down? Is there a pattern you could write that down? Why does the pattern exist? Think about that. What about tangent and sine would cause that pattern to exist?
Because,
Well, let me tell you what the textbook has, and then here's what I want you to do. I'm going to tell you what the textbook has, and then I want you maybe for a little fun, you guys can try to figure this out. There's two types of isotopes. One isotope occurs when A is equal to 4k plus 1, where k is an integer, times pi over 2. And the other vertical isotope occurs when 4k plus 3 and k is an integer. So that one's kind of a goofy one. That's what the textbook said. So look at that later and see what you come up with.